in this video I want to go through some of these numerical response problems. So this is the worksheet that you had for homework. The first 8 problems are just calculating surface area to volume ratios. So that's something that we covered in class. It's in the notes, and there's a video on that already. But I'm going to start with number 9 and work out the rest of them for you, because these are sort of numeric response. Some of them require you to analyze a graph and use a little bit of dimensional analysis. And we haven't really talked about this in class. There's an expectation that you already know how to do this. But just in case you don't or you forgot, let's do a quick walkthrough. So a common thing they'll ask is how many times more something is than something else. So you notice here, how many times larger is the surface area of a white blood cell compared to a bacterium? So they're not just asking how much bigger is it, like in micrometers, how much bigger it is. They want to know how many times bigger it is. So anytime they ask how many times larger something is, what you're going to do is you're going to put your bigger number over your smaller number and see how many times does my small one go into my big one. And that's going to give me how many times larger or how many times more something is. Now, if they just ask how much more or how many micrometers more, then you're going to subtract. And I'll show you an example of that in a minute. So in this case, this is actually about surface area as well. So they want to know how many times larger is the surface area of a white blood cell compared to a bacterium. Now, you are given the formula sheet, remember. So we talked about how to calculate surface area. So surface area is calculated as 4 pi times the radius squared. So for the bacterium, that would be 4 times pi times 1 squared, which is going to give you a surface area of just 4 pi. And that would be micrometers squared, although that isn't really important for right now. Okay, and now for our spherical cell, 4 times pi times 10 squared, and that's going to give me 400 pi micrometers squared. Now, they want to know how many times larger. Now, the reason I did not multiply out pi is because we're going to divide here. So if we want to know how many times larger, so 400 pi over my smaller one, 4 pi, when I divide that out, pi is going to cancel. 4 goes into 400 100 times. So what we're saying is that the surface area of a white blood cell is 100 times larger than that of a bacterium. So that's how you would solve a problem, any problem, where they say how many times larger or how many times more. You're going to divide your bigger number divided by your small. Okay, so let's move on now to our next set of questions. Now these are based on a graph. So they have a whole explanation here, but to be honest, it's not that important. It was an experiment that was done with coral, and you have what's called a calcification rate, and they're talking about, in this case, the amount of carbon dioxide in the air and how much calcium carbonate gets incorporated into the coral. But the questions we're answering really don't have anything to do with that. They just have to do with, can you read the graph? So here's the first thing I want you to see. So this graph has a rate of millimoles per meter squared per day. What does that mean? That means that if I have a coral that was only a single square meter, then the amount I get on this graph would be how many millimoles of calcium carbonate it would have. But if the coral is bigger than just 1 square meter, since this is a rate, I would need to multiply by its size. Sort of like if you make $10 an hour, right? That's only for 1 hour. If I say, okay, well, how much money will you make if you work 6 hours? You should know that you would multiply by 6 because this is my rate per hour. Well, it's the same thing here. So this is how much per square meter, which is an amount, an area of coral, per day. So this is how much it would make if the coral was only 1 square meter and you let 1 day pass, then the number you get on this graph would be your answer. But if the coral is bigger than 1 square meter, or the time that passes is more than a day, then you're going to have to multiply. So let's take a look at some of these questions. So the first question says, if seawater carbonate concentration is 260 micromoles per kilogram, what is the approximate rate of calcification? So they actually want you, it says to use the line, because remember this is one of those line of best fit sort of things. So we're going to use the line, not the individual data points. And for question 10, this is actually really easy. We're just going to look for 260 millimoles per kilogram in the seawater. So here's 260 here, and we're just going to look at where this graph hits. So if I notice my scale on my y-axis, it should be 15, or approximately 15. You might estimate, maybe you estimate that it's slightly less, but we're going to go with 15. So, and your units here for number 10 then would be, so this is for number 10, it would be 15 millimoles calcium carbonate per square meter per day. Because that's the full units. If this is a free response, remember you should always include your units in your answer. Okay, so that's number 10. Now let's look at number 11. This is where you start having to use some of this dimensional analysis. So using the rate you got in number 10, how many days would it take 1 square meter of reef to accumulate 60 millimoles of calcium carbonate? So let's take a look. So remember, our answer to this one was that it was 50 millimoles of calcium carbonate per square meter per day. Okay? So they want to know how many days would it take to get 60 millimoles. So think about this. So if it's 15 millimoles per 1 day, and they are telling you that this is just for 1 square meter of reef. So it is just for this amount. So we don't need to worry about that. So it's 15 millimoles in 1 day. We want to know how many days would it take to get 60 millimoles. So the easiest way to do this, my suggestion would be to do this. It would be 60 millimoles in X number of days. And then we can cross multiply. We would get 15x is equal to 60, and that should give you 4 days. So this is hopefully a little bit of common sense. So this is how much you do in 1 day. So if we wanted to do this many millimoles, how many days? Now let's take a look at the next one, number 12. So it says that the Biosphere Aquarium where the experiment was conducted has a surface area of 35 by 20 meters. Now the first thing you need to know is, remember how our units were per square meter. Well, remember, surface area is length, basically length times width here. So if the surface area is 35 by 20 meters, if we multiply that out, that's 700 square meters. Okay, so now we know the size of our tank. So they want to know how many total millimoles will be created after 1 day. Now remember, our rate was per day, using the same rate we calculated again in number 10. So we have 15 millimoles per day. They're already saying 1 day, so we're going to ignore that. So it's millimoles per 1 meter squared. But they're saying that instead of it being 1 square meter, they're saying the size of the tank is 700 square meters. And they're asking how many millimoles. So look what we can do. We can, again, set this up. 15 millimoles per square meter would be how many millimoles in 700 square meters. And if you cross multiply 700 times 15, you would get an answer of 10,500 square meters. I'm sorry, millimoles, not square meters, millimoles. That's what we were looking for. So that is how many millimoles if it was 700 square meters. All right, and now let's look at this last one. Now, pay close attention here because I could ask you and they could ask you either of these two questions. This says how many times higher is the rate at 270 versus 260. But they could also ask you how many millimoles per kilogram higher is the rate at 270 versus 260. In other words, let's do how many times higher first. So remember what I told you. If you want to get how many times higher, you're going to put your bigger number over your smaller number. So what we're going to do is we're going to look up the rate at 270. We're going to look up the rate at 260, and we're simply going to divide those. So let me go back up here. So our rate at 270 is approximately, I'm going to go with like 19, let's just say. That's millimoles of calcium carbonate per meter squared per day, so 19. And at 260, remember we're going by the line, I'm going to say this is approximately 15. Now they're always going to allow some wiggle room, by the way, if it's an estimate. So if it's 19 versus 15, so let's go back down here. So we just said that our rate at 270 was 19 millimoles per meter squared per day, and at 260 it was 15 millimoles. So they want to know how many times higher. We would do 19 over 15. How many times does 15 go into 19? And I believe 15 goes into 19 1.2 times. And so that would be how many times higher. Now, if you estimated, I get 1.26. So 1.3 if we were going to round, so 1.3. The acceptable answers here, since your estimate of those two numbers might have been different, like you might have estimated this top one closer to 20. So 1.2 to 1.3 would be correct. But on the other hand, what if I just said how many millimoles more is it at 270 than 260? So if my question instead was how many millimoles per square meter per day more is the rate at 270 versus 260. Now, I'm not asking the same question, right? I literally want to know how many more millimoles, not how many times more. So I would just do this, 19 minus 15. And my answer would be 4. So it would be 4 millimoles per square meter per day more. And if they asked after a certain number of days, you would again calculate your total on your bigger one minus your smaller one, but you're not dividing here. So if it's how many times higher or how many times more, that's where you're dividing. If they literally ask you how many millimoles more, or how many milliliters more, how many grams more, or whatever, you'll get your two answers and you'll subtract. So remember, some people may have estimated 20 for that top number, in which case then your answer would have been 5 millimoles per meter squared per day more. They could ask, like, how many more millimoles after 5 days, in which case, again, you would have to get how many for 5 days, not just per day, but again, you'd be subtracting. So that's the difference in how many more versus how many times more. So hopefully this was helpful in how to do some of these math problems, and particularly how to interpret data when you have a graph like this that has a y-axis that is a rate. So again, it's sort of like a pay rate. So this is only per meter squared. So if it's multiple meters squared, you need to multiply. If it's over multiple days, you need to multiply. So keep that in mind, and of course, see me if you have any questions.